Okay, hello everyone. It's great to be here with you today. Let me briefly introduce myself. My name is Sun Shiyu, and I'm from China. My presentation today will focus on a case from the paper, Implementation of the Lean Principles to Improve the Operations of a Sales Warehouse in the Manufacturing Industry. The detailed information of the paper is shown at the bottom of this slide. You can see here. And I'll deliver my presentation from the following aspects. A brief introduction of the Lean principle in manufacturing industry. Case study, including background of the case. Lean tool, the study of existing system. Lean solutions and the corresponding results. And my own of how the warehousing processes in this case can be further improved. So let's begin with the Lean principle in manufacturing industry. Industry should be flexible enough to meet the needs of customers. So it's necessary for manufacturers to provide high-quality products or services quickly and at low cost. Industries are looking for new tools and technologies to produce products to compete and survive in the marketplace. One promising approach is to apply Lean principles and techniques. Lean manufacturing, simply called Lean, is a production practice that identifies and eliminates waste in existing activities in order to achieve continuous improvement and better productivity. In addition, it improves the response time to customer demand, reduce inventory, reduce costs, and improves productivity. And in terms of lean warehousing, a lean warehouse will continuously improve processes through use of lean tools and techniques. Sandeep also agrees that lean in warehousing further leads to waste elimination and creating more value to the customer. Therefore, it is feasible and necessary to apply lean technology in manufacturing industry. After understanding what is lean and lean warehousing, today we will discuss a real case study of lean warehousing. This paper describes the application of lean techniques in a sales warehouse of a reputed manufacturing company in India. And this picture shows the models of the existing layout of this warehouse. As we can see, the layout of the warehouse is L-shaped, with receiving areas, here is the receiving areas, and docks at different ends, meaning that each ordered product must be shipped from one side to the other before loading. There are two docks for loading parts. In the parking area, each shift can be loaded up to 12 vehicles. The assembly line since items packed in the cardboard boxes and pallets to the warehouse, and the packaged products come from the assembly line. The order will be picked after the arrival of the vehicle and be selected and the selected products will be uploaded to the shipper on the gangway. As you can see, items placed on the gangway, and this is the gangway. This paper mainly utilizes the Lean tool, VSM, and layout changes to solve the problems. So, what is VSM? VSM means value stream map. A value stream is a collection of all specific actions or processes, both value-added and non-value-added, that require information from production or warehouse operations and production processes to capture products. The VSM is a diagram that shows all the processes in the warehouse and the flow of information and a material through those processes. Through the VSM, the warehouse manager can discover the waste in the warehouse and identify possible improvement opportunities to eliminate the waste, improve, improve productivity, and improve accuracy. There are two types of VSMs. One is current state maps, and the other is future state maps. Drawing the current state diagram after observing current activities helps to identify all wasteful activities, and then a map of the future state is drawn to show the effect of the eliminating all wasteful activities. Okay, now we can see the current state value stream map here. It can be seen that scanning, warehousing, also called storage, and inspection, order picking, and delivery, and docking are the main operations of the warehouse. The following table is waste identification found on the map. The waste observed includes delayed scanning, block material flow, improper storage, storage delay, high order picking, and vehicle loading delay. These results show that unreasonable storage directly leads to high pickup time and vehicle loading delay. After identified waste, some link solutions are given respectively. This table shows the summary of waste solutions. Now, let's look at these measures in detail. First is delayed scanning. The delay in scanning is due to the 7.5 meters distance between the scanning area and the products. Thus, the operator has to move 15 meters for each scanning and data entry activities. To reduce scanning time, the scanning area is moved nearer to the gangway and the distance between them has been shortened to 1 meter. Next is delay in movement. Material obstruction mainly occurs due to the clash between inward and outward flow, which can be solved by changing one-way gangway into two-way. There's one-way, there's two-way. The directional arrows shown in the figure reveal that the inward and outward flow are separated, so that the clash between them will be reduced. This will greatly reduce the error rate. Then for high-level loading time, according to the VSM, there are only 12 vehicles which could load per shift. However, in each shift, there are nearly 20 vehicles arrive at the warehouse, so that some vehicles need to wait at the docking area, sometimes may cause congestion. Besides this, at first, order picking was done only after a vehicle entered the docking area, since there are no extra to place or so much time waiting for the products to load. Based on the Lean principles, to eliminate this waste, two marsh yards, as you can see, marsh yards, were implemented next to the dock, where ordered products could be placed before the vehicle loaded. It is an ideal approach to reduce waiting time for order picking. The last one is unnecessary movement during storing and order picking. As shown before, the warehouse has an L-shaped layout that the producer needs to move from one side to the other, which is a long distance and wastes so much time. To improve this, the L-shaped layout has been changed into U-shaped. As you can see, U-shaped, shipped items to be stored are classified into three categories based on ABC analysis, and the cross-docking distance has been shortened from 67.5 meters to 30 meters. A item should be placed nearer to dock area, while B and C items should be stacked afterwards. ABC storage analysis is used to reduce order picking time. It's a method of storage categorization in which items are classified into three classes, A, B, and C. Figure below shows an ABC analysis graph of the sales value of products sold to customer, A class, B class, and C class. After work out the link solutions, a future state value stream map was shown before implement. Here are the results after implementation. It can be shown that each warehouse operation is improved by value stream mapping and layout changes. This figure shows operation times of the previous layout and new layout. It is clear from the figure that the new layout improves the operational efficiency. For example, scanning time reduced from 59 to 35 seconds. Inventory verification time reduced from 102 seconds to 69 seconds. The order was announced by ABC Stock, and the picking time was from 335 seconds to 180 seconds. Dispatch time reduced from 77 seconds to 61 seconds, and the docking time reduced from 129 seconds to 77 seconds by the Marsh Yard. The table below shows the results of the VSM and layout change solutions. As we can find that the time spent on each process or have been reduced in a large percentage. So, in addition to the methods mentioned in the article, is there any way to further improve the warehousing problem involved in this case? Here, I would like to make two suggestions for minimizing the time spent on scanning and reducing unnecessary movement during storing and order picking, respectively. First, a heterogeneous UAV-based robotic system can be used to minimize the time spent on scanning. Unmanned aerial vehicles, which is UAVs, with autonomous navigation and environmental awareness are emerging rapidly in logistics, transportation, monitoring, and other industrial fields. Using them to carry out inventory checks in warehouses has advantages of saving time and cost compared with manual checks, and avoids the risk of injury to workers who perform manual barcode scans. Researchers have described a heterogeneous UAV-based robotic system for real-time barcode detection and scanning. The method improves the positioning of the UAV using scanned barcodes as landmarks in a real warehouse under low light conditions, instead of using standard overlapping snake-based mesh, which is OSBG trajectories. They implement a flight path optimization method based on barcode position. This method reduces the time of stock taking and the number of barcode scanning errors. Then, warehouse mapping according to FSM classification can be used to reduce unnecessary movement. What is FSM? F is fast moving, S slow moving, and N is non-moving. FSM analysis can be used to determine the location of the storage goods to be allocated closer to the loading bay. Items will be classified to improve item movement, including dwell time, average dwell time, and how often items go in and out of the warehouse, which is what we call consumption rate. Average residence time means that inventory is classified according to how long it has been in storage until it is used or shipped. The consumption rate is when high demand products are allocated to slots close to the aisle door. Goods and fast moving categories are assigned close to the loading dock. Slow moving items are placed next to fast moving items, and non moving items are placed next to the slow moving items, which are furthest from the loading dock. And that's my presentation today. So thanks for listening. Do you have any questions? And here is the reference list for me. Okay, thank you today.